Thunder woke me up, and then my kiddos come crying after that. So
Yep.
they all had to come get in bed with me.
So let's start with 8.2, and we're looking at graphing polynomials. So before we get into the actual graphing on these, the first few questions, they want us to take a polynomial function and determine what is the maximum number of zeros it can have, what's the maximum number of x-intercepts it can have, and then what's the maximum number of turning points it can have. So for a polynomial function, so we're going to look at three things. So the first thing is the maximum number of real zeros. So the maximum number of real zeros is equal to the degree of the polynomial. And just remember, the degree of that polynomial is the highest exponent, okay? So that tells me what the maximum number of real zeros is. Now it can have less zeros than that, but that's the maximum it can have. So if you got an x to the 4, that means that the maximum number of real zeros it'll have would be the 4, okay? The maximum number of x-intercepts is next. So the maximum number of x-intercepts is equal to the degree of the polynomial. You know, that makes perfect sense because remember, y'all had the problems where you was finding the x-intercepts and then it asked you for the zeros, which were the solutions. So the x-intercepts, those x values are equal to the zeros. So since x-intercepts are equal to zeros, these both are going to be equal to the degree of that polynomial, which is the highest exponent. Now, the one that's a little bit different is the maximum number of turning points. So the maximum number of turning points is equal to the degree minus 1. So when we was looking at the x-squared graphs made a nice U-shaped parabola. So the degree is 2, which means it would have 2 real zeros max. It would have 2 x-intercepts max. But the turning points here, if you subtract 1 from the degree, 2 minus 1 gives me 1. So a parabola only turns 1 time. Okay? So zeros equal to the degree, x-intercepts equal to the degree, turning points equal to the degree minus 1. So let me show you a few examples on those. So for these examples, for the polynomial, find the maximum number of real zeros And you'll learn later, we're talking about real zeros because some of these zeros can be what we call imaginary. Remember when you deal with those square roots, like the quadratic formula, sometimes we got imaginary answers on that, okay? So find the maximum number of real zeros, maximum number of x-intercepts, and finally, maximum number of turning points. Okay, so we'll look at 3 of these. So my first one, f of x equals x to the 4th minus x to the 3rd plus 2. So we're going to find the maximum real zeros, the maximum x-intercepts, and then the max turning points. So I guess y'all, the trick of this problem is to figure out what is the degree of this polynomial. Once we know the degree of this polynomial, we got A and B for our answers. And then on C, we subtract 1 and get the maximum turning points. So remember, the degree is the highest exponent. Highest exponent I have is a 4. So this is definitely a degree 4 polynomial. That means the maximum number of real zeros is equal to the degree. So that means I have a maximum of 4 real zeros. X-intercepts, we said, were the same thing as the zeros. So we're going to have a maximum of 4 x-intercepts. So what that means, if this was a graph, this graph is coming down, might go up, down, and then up again. So say that was your x-axis. So notice here's 1, 2, 3, 4. So that's what they're talking about. It's going to cross the x-axis 4 times, maximum, which means it also has 4 real zeros possible. Now remember, the reason we're looking at the maximum, because this graph could come down, turn up, and do like this, and then go up. Same graph, it's just shifted down a little bit. But notice this one only has 2 x-intercepts and 2 real zeros. Okay, but that's why we're only concerned in these problems with what is the maximum it could have. All right, y'all, and then turning points, the maximum number of turning points we said was the degree minus 1, which will give me 3. So notice on the one I drew, it's turning right here 1, turning around here twice, turning around here 3 times. Okay, now that's the maximum number this one could turn, because it's only a degree 4. All right, y'all, so hopefully them are making sense. So let's look at number 2 here. So number 2, they're giving us f of x equals x to the 9th minus 3x to the 5th plus a 4x minus 3. So we want our maximum real zeros, our maximum x-intercepts, and then our maximum turning points. So y'all, I'll let y'all answer this. What do y'all think the maximum real zeros are?
9.
So it's going to be 9 because this is a degree 9. All right. How about my maximum x-intercepts?
9.
All righty. And then you got one more, maximum turning points.
8.
8. There you go. See, all these problems ain't going to be bad on you as long as you remember where that degree is and how we're finding those, okay? So ain't much I can do to these other than this next problem. How about a negative 9x minus x squared? So we're going to find our maximum real zeros again. Our maximum x-intercepts. And then our max turning points. All right, y'all. So how about my maximum real zeros?
2.
I think it's 2. Yeah.
Oh, good job. So the only thing we can do is maybe put them out of order, but good job. Y'all found a degree of 2, which means my max intercepts.
2.
And then my maximum turning points.
1.
1. There you go. Remember, these x squared graphs are these parabolas, and they only turn once, so there you go. All righty. So for the next examples, I'm actually going to go to the math lab because they're more graphing. So let me share the math lab. This sort of goes back to what we did yesterday on most of these. Remember that in behavior chart we made, okay? Because these are going to go off of that chart we made. And y'all, let's make another chart real quick in case I didn't have anyone here. So we're looking at the in behavior. Because that's the easiest way to figure these graphs out is by looking at the in behavior. Now, some of them I'm going to have to do a little bit more to pick out the graph. But for the big part, in behavior. So remember, we looked at the degree. The degree was even or odd. We compared that with the lead coefficient. The lead coefficient could be positive or negative. So that gave us 4 choices here. Positive lead coefficient, even degree, both ends went uphill. A negative lead coefficient with an even degree, both ends went downhill. If it's a positive lead coefficient and an odd degree, those went uphill left to right. And if it was a negative lead coefficient and an odd degree, it went downhill left to right. Because probably more than half of these can be done just knowing these shapes of these graphs, okay? So now let's go back to the math lab. And notice I got a U-shaped graph, one that's flipped over. C is going uphill left to right, and D is going downhill left to right. So I'm looking at my degree, which is a 2 for this one. I got an even degree. So then I look at the 1/5, which is the lead coefficient. That 1/5 is positive. So when we had a positive lead coefficient and an even degree, would we pick A, B, C, or D?
A.
A, because both ends have to go uphill, and then it was a positive lead coefficient. So then we check that and go to the next one. All right, so my first one, both ends are going down. B is going uphill left to right, and C is going downhill left to right. This has an x to the 5th as the leading term. It has a degree 5, which is odd, and we treat it like a positive 1 in front of that x to the 5th. So since there's no lead coefficient, we treat it like a positive 1. So you got a positive lead coefficient odd degree, A, B, or C?
B.
Say B is in boy.
Yes.
Okay, good job. Because odd and positive goes uphill, left to right. Right, I got an X to the 4th. And it's got a 1 in front of it. So it's positive and even. But y'all look at this. 2 of these graphs are going uphill. So what you got to do is figure out which one of them. Y'all see that negative 19 at the end on this graph? That negative 19 is the y-intercept. So whatever number's at the end is where it's supposed to be crossing this graph at. And if you'll notice under here, it's telling me that the X scale is going by 1s, but the Y scale is going by 10s. So every mark on this Y-axis is going by 10s. So I'm going to blow up the 2 that look like they're possibilities. Now, if you notice the first one, if you look where it's crossing the Y-axis, if these marks are 10, that thing is pretty close to where that negative 20 would be. If you look at B, that one crosses just 1 mark down. So that's telling me that that one's crossing at around negative 10, since the Y scale is going by 10s on this. So, y'all, we got a choice between A or B. Which one looks like it's crossing at that negative 19?
A.
A, so there you go. So sometimes we look at that y-intercept, which is that last number, to sort of distinguish between 2 different graphs that look the same. All right, let's see. A is going downhill left to right. B is going uphill. C, both ends are down. And D, both ends are up. So this one, we should be able to get a nice clear picture of one of these 4.
A.
I got an, oh, what'd y'all just say?
A.
Oh, you're quick, because that's 5 is my degree, so it's odd. It's got a negative 1 in front of it. Good job, because if it's negative and odd, it's going to go downhill, left to right, like A. So they're really not too bad when you got a chart. So what are y'all putting here? X to the 5th minus X to the 3rd. A, B, C, or D? Because you got both ends going down. B is downhill left to right. C is going uphill. And D, they're both going up. So it looks like we got an odd degree of 5 and a positive 1 for the lead
C.
coefficient. So good job. C is going uphill left to right. Now don't worry, they'll get a little tougher here in a second. Oh, here's one right now. So it looks like A is going uphill left to right. B, both ends are going up. C, looks like both ends are going down. And y'all, that D's got a lot going on. So let me zoom it up a second. So that D looks like it might be going uphill left to right. It's hard to tell on that. And, so what I'm going to do on this one is show y'all how to actually graph this to get the exact picture they got. So if I want to graph these, I'm going to go to my, let me write this down real quick. So h of x equals x minus 4, x plus 1, and x minus 7. All righty. Now notice on their graphs, their graphs, the x's go from -10 to 10. So I'm going to keep that the same. But those y values are going from -100 to a +100. Now, our graphs in the calculators are set by default at 10 and -10. So I'm going to show you how to change the window, and you'll get exactly one of those 4 pictures. So 2 ways I'm going to show you how to do this one. So let me go to my pad first. So y'all, one way I do this is by figuring out what my degree of this would be. So to get the degree of this polynomial that it's in factored form, all we got to do is multiply all these x's together. All the x's. If we multiply together all these x's, I got an x times x times x times x. And they're all positive x's. So if you multiply all 4 of them positive x's, you'll get a positive x to the 4th. So this is one way I would do it. All right. So I got an even degree, positive lead coefficient. And if you look at our picture, when it was positive and even degree, both ends are going to go uphill, which looks like what B is doing to me, right? Looks like both these ends are going uphill. Now, I'm going to look at this on the calculator. So what we're going to do first is go to y equals and put in that equation, x, and then parentheses, x minus 4, and then parentheses, x plus 1, and then parentheses, x minus 7. Now, before I graph this, I'm going to set the window of my calculator because those y values were going from -100 to a +100. So to change the window, you go up here to where it says window and change that by hitting window. So notice it's got my x minimum at -10, x max at 10. We're good with that. So I'm going to go down here to the y minimum. The y minimum is what I'm going to change to a -100. And then I'm going to go down one more and change the y maximum to a +100. All right, so let me go back and show y'all the actual problem. So I'm doing that because I'm just looking at the graph, and that's what numbers they're giving me on the graph, okay? So let's go to this calculator. We got a window set. Let's hit graph. All right, y'all, so I think we was right because look at that graph. Looks like a W. And if we went back to our math lab, that looks like RB here. So if I zoom up B, it's got that same sort of W shape to it, okay? So notice 2 ways that I did that. I multiplied all them x's together. Then I knew I had that shape. Also, I went in there and I graphed it. And when I graphed it, I got the same graph, okay? Now, if you want to set this calculator back to a 10 by 10, to reset it back to normal window, you would hit that zoom button and go to number 6. Number 6 means you're going back to a standard screen for your graphing, okay? So I would hit enter. So now it's harder to tell that graph when you're at the normal screen. That's why I changed my window. If you look at this normal screen, I doubt we could even pick a graph doing that. But y'all look what it did to my window when I hit the window button. Ooh, what'd I do here? Let me see what happened here. Oh, I know what it is. It's because I did the did I not hit 6? Let me see. Zoom 6. All right, so that's back at the 10 by 10. All righty, y'all. So Different ways to do these, okay? So we pick B, we would move on. All right, so let's see, we got a graph going uphill, one going downhill, B, C, they're both going uphill, and D going downhill. So let me show you what I would do to that. I'm going to write this down real quick. G of X equals a negative X times X minus 1 squared times X plus 2 squared. All righty, so I'm going to multiply all my X's together. But y'all, I'm not just going to multiply negative X times this X times this X, because I got exponents out here. Remember, these exponents are the multiplicity. So this is really negative X times X minus 1 times X minus 1. Remember, multiplicity means this factor happens twice. And then this X plus 2 happens twice. So now let me multiply all these X's together. And y'all look at one thing. This first X is negative. So since I got a negative and all the rest of the X's is positive, that's going to end up being a negative X. And let's say I got 1, 2, 3, 4, 5 X's. So that's going to give me a negative X to the 5th, which means I got a negative lead coefficient and an odd degree. So that means this graph should be going downhill left to right. So let's look at the math lab. Downhill left to right. Well, y'all, I got B going downhill left to right. And I got D going downhill left to right. So what we got to look at now are the zeros of this thing. So notice, negative 1 is giving me a 0 of 1. So it should be touching the x-axis at 1. And then that plus 2, the 0 would be negative 2. So it should be touching the x-axis at negative 2. So B is doing that perfectly. So y'all, let's look at D. If you look at D, they got them backwards. They got it touching at negative 1 and positive 2. But remember, negative 1 is not the 0. The 0 is when you set x minus 1 equal to 0 and you get a positive 1. So D has them backwards. It's using a negative 1 and a positive 2 instead of our negative 2, positive 1. So, y'all, what I'm looking at on that are these factors. I would set x minus 1 equal to 0. Add 1 to both sides. So that tells me 1 is a 0. And it crossing at that x-axis at the x value of 1. And then over here, the x plus 2, set it equal to 0. That was going to give me negative 2. So it's got to be touching these two values on the x-axis. And y'all, that's why I went with A on that one. I mean, not A, but what is that? B. Okay, because it's touching at negative 2 and positive 1. So be careful on that because you got two pictures that look exactly alike. And y'all, this one looks like it's doing the same thing. A and B are both going uphill. I mean, not uphill, but both ends are going up. C, both ends are going down. And then D looks like it's going downhill left to right. So let's think about this. And I got 2 X's from the first one because of that multiplicity 2. I'll have 2 X's from the last one. So I'm going to write these down real quick. So this one I got f of x equals x plus 2 squared times x minus 1 to the 4th. Now remember, on these, you could graph them and set your windows like they got them, okay? So remember, this is like a x plus 2 times x plus 2 times the x minus 1, 4 times on that x minus 1. So basically, all the x's are positive, so I would just multiply all these x's together. And I get an x. Let's see, I had what? 1, 2, 3, 4, 6 of them. So we get an x to the 6, and it's positive, so it's going to be both ends are going to go uphill. So what I need to do, because I know 2 of these graphs were really close, I need to figure out where the zeros are. So for the x plus 2, we would subtract 2. And it's telling me that I got a 0 at -2. So it's got to touch that x-axis at -2. On the x minus 1, I would set it equal to 0 and get x equals a positive 1. So it's got to go uphill on both ends. One side has to touch that -2 on the x-axis. The other side has to touch a positive 1. So I'm sure they're going to get them backwards like they did while ago on that last problem. So we're looking at A and B here. So let me zoom them 2 up. So if we look at A, it's touching the x-axis at -2, and the right side's touching it at positive 1. If you look at B, its left side is touching at -1, and the right side is touching it at a positive 2. So between the 2, I had to touch over here at -2 and 1. So we're going to choose A for that one. So y'all, that's how you got to distinguish when you got 2 graphs that look like what you need. Look at where they're touching those x-axis is that, okay? So we would come down, check that answer. Now the last one, let's see, both ends up. B's going uphill left to right. C is going uphill left to right. And then D is going downhill left to right. So this one, I got an odd degree of 3. I got a positive lead coefficient. So positive and odd go uphill left to right. So y'all, once again, I'm stuck with B and C. So let's look at what B and C are doing. Now notice, my y-intercept on this one is 81. So y'all, between B and C, which one looks like it might be crossing that x-axis at an 81? Well, y'all, let me zoom up B one more time. Look at B, y'all. It looks like it's crossing the y-axis right at 0, don't it? It's going right through the center. So then let's look at C. So C is hard to tell. So let me see. These look like they're going by 50s on those marks, because that's going up to 250. So those are going by 50s. So if you look at it, that thing's in between 50 and 100 on C. So I would say that is probably closer to 81 than it would be for B. B is going right through the center, which means that y value is 0. So y'all, it's got to be C. So we would check that answer and be done. So y'all, that is the trick with 8.2 is using that in behavior chart and then just picking a graph, okay? And then you got to know a little bit about y-intercepts on some of them. And then some of them you had to know just a little bit about those zeros. Where were they touching my x-axis at? All right, y'all, so this next section will be a little more fun if you like math. 8.3, this deals with polynomial division. And really, we're only going to look at one type of division. We're going to look at what we call synthetic division. And we'll use synthetic division for 3 different things. The first thing I can use synthetic division for, I can use it to find function values. So what I mean by finding function values, I can use it to find stuff like f of 5 if they give me a polynomial. Normally, I have to plug into 5 and then do all that order of operations stuff, but I can use synthetic division to find these function values. And we got a little theorem that we call the remainder theorem. And the remainder theorem says that the remainder from doing synthetic division is equal to the function value. Okay, so to find function values, I do my synthetic division, and whatever remainder I get, that is equal to the function value. The second thing we'll use it for is to determine whether a number is a zero of a polynomial. So I can use it to tell whether numbers are zeros of a polynomial. So here's the thing on that. If a number is a zero of a polynomial, then the remainder must be zero. So if I try to check a number to see if it's a zero and I go through my synthetic division, if my remainder is zero, then yes, it's a zero of the polynomial. If my remainder is any other number, then I would put no, it's not a zero. You know, we'll work through examples of all of this. Now, the support, there's 3 problems in support. And what we do with synthetic division in support, we're using it to find the quotient and remainder of a polynomial being divided. Okay. So quotient or remainder. I'll show you how we figure out what the quotient is and the remainder when we do polynomial division, okay? So this one we'll do, and I'll do you 1 or 2 support examples showing you this. For college algebra, it focuses on the function values and determining whether a number is a zero. So y'all, what I'm going to do, I'm going to work example while I list out the steps that we're going to do, okay? So for this example, I'm going to use synthetic division to find the function value. So they're giving me f of x equals x to the fourth minus x to the third minus 13x squared plus 49x minus 25. They want us to find f of 4. All righty, so here's going to be the steps on the side. The first step we do, we're going to write out the coefficients of the polynomial. Now, here's the thing on this part. If there's any missing terms, then we must put a 0 for that spot. So then we must put a 0 for that spot. Now, I'll tell you the truth about that. College algebra, those examples I'm doing on it, I don't think any of them will have a missing spot to worry about a 0. When I do some of the support ones, there's 1 or 2, I think, that you got to worry about the missing spots, okay? But let me check real quick. All the ones for college algebra actually have all the places there, okay? So write out all the coefficients. So here's my x4, x3, x2, x term, and my number term. So the coefficients are just a number. So no number in front of the x4 means it's a 1. x3 would be a -1. The x squared term is a -13. The x term is a 49. And then the number at the end is a -25. So I write out all my coefficients. Then what I'm going to do, under those coefficients, leave a little space here. But then I'm going to draw me a box. And I'm going to close off the last section of my box under that -25. This right here will be my remainder that I put in this box. So this box is going to be the remainder. All the numbers I get under this part later on will be the quotients, okay? So here, draw the box under the coefficients. So we draw our box. Now, put C. C is going to be over here. We're going to put C over here. C is what number you're evaluating. So I'm finding f of 4. So 4 will be what I put in for my C. So C is always what we're checking. Put C to the left. All right, so I got my C over here to the left. All righty. Now, normally, by hand to find f of 4, we'd have to put a 4 in here, a 4 here, a 4 here, and a 4 here. Then we'd have to do exponents and then add, subtract, and all that fun stuff. Watch this synthetic division. It's pretty smooth. So the first thing you're going to do, the first number automatically we bring down below the line. Okay, so no matter what that first number is, it's automatically going to come down all the way to the below that line. So bring the first number down. once I bring that number down, any number down here below the line, we're going to multiply by the C to get the next column. So I'm going to multiply the number brought down by C and put in the next column. All right, so I brought the 1 down. 1 times 4 is 4. So I'm now going to put that 4 into the next column. Now, to get the next number under the line, we're going to add this row up. So add the column. All right, y'all. So -1, +4 gives me a +3. So now I'm just going to repeat the process until done. All right, the 3 is now below the line. So guess what? The 3 is going to multiply by the 4. So 3 times 4 is 12. That 12 now goes into the next column. So I now have a column of numbers. We're going to add this column up to get the next number below the line. So -13 and +12 give me a -1. Now, I got a number below the line. So that number will now multiply by the C to get my next column. So -1 times 4 gives me a -4. All right, y'all. I got a column here. We're going to add that column to get our next number below the line. 49 minus 4 is going to give me a 45 now. So now I got a number below the line. I'm going to multiply by the C to get my last column here. So 45 times 4, let's see, that's what, 180. So y'all, once I add this last column, I'll have my remainder. And remember, we said up here, the remainder is equal to the function value. So let's see, 180 and a -25. What's that giving me? 155? Which means f of 4 equals 155. Now, if you'd have put a 4 here, 4 here, 4 here, 4 here on your calculator, guess what? It would have gave you 155. So y'all, that's what this is. This is synthetic division, and all we use are the coefficients and then the number being evaluated. And remember, the function value is equal to that remainder. So questions on that yet? Because we'll do plenty of these. All right, y'all, so let's turn this over. Let's do more function values. So let me get the page back. So we're going to use synthetic division to find the function values. So find the function values. So they're giving us f of x equals x to the third minus 13x squared plus 52x minus 60. They want us to find f of 2, f of a -5, and f of 6. So 3 problems in one, okay? So I'm going to have to do synthetic division 3 times to find all these function values. So y'all will do this one and then we'll take a break, okay? So here's the thing. First thing we got to do is write out the coefficients. So x3 has a 1, x squared is a negative 13, x term is a 52, and then my number at the end is a negative 60. So notice, no missing terms. I had my x3, x squared, x, and my constant number. So then we're going to come under here and draw our box. And I'm going to box off that remainder, remember. So y'all, my first C is the first number they want me to check, which is a positive 2. So I'm going to put my 2 in for my C. All right, y'all, here we go. Let's spin it. So bring down the 1 all the way below the 9. Now we're just going to repeat our process till we're done. 1 times 2 is 2. So bring that in the next column. Negative 13, positive 2 give you a negative 11. All right, negative 11 below the line now multiplies by the 2. So negative 11 times 2 is a negative 22. I now have to add this column. 52 negative 22 will give you 30. All right, I got a number below the line, so I got to get this last column. So 30 times 2 is a positive 60. And y'all look at that. Negative 60, positive 60, give me a 0 remainder. But that means f of 2 for this function equals 0. Which also means this, don't it? If I got a remainder 0, don't that mean that 2 is a 0 of that polynomial? That means that this graph will cross the x-axis at that 2. But y'all, you ain't got to know all that for now. All you got to know is that remainder equals that function value. All right, so now let's find f of negative 5. That c will be negative 5. And I'm going to use the same numbers again. 1, negative 13, 52, and negative 60. Make my box under that, and then square in my last one. All right, y'all, here we go. Bring the 1 down. 1 times negative 5 is negative 5. Now, they're going to mess with you with adding these like signs and unlike signs and stuff. This one right here is where I get the most mistakes. A negative 13 and a negative 5 is not a positive number. Like signs are only positive when you multiply and divide. When you add 2 negatives, they stay negative, okay? So negative 13 and negative 5 give me a negative 18. So now, negative 18 times negative 5. That's going to be a positive 90. All right, y'all. So now we're adding this row. So that's what? 142. We're getting big numbers here. All right, so I need that last column. So I got to figure out what that 142 times that negative 5 is. Well, y'all, that's giving me a negative 710. So I'm going to add that negative 710 and that negative 60, and that gives me a negative 770. So if I put a negative 5 into this equation, that's what it's going to give me, negative 770. So that means f of negative 5 equaled a negative 770. All right, y'all, one more. We got a 6 here. So my next C will be 6. I still got the same numbers that I'm using. All righty, so first step y'all want me to do.
Bring your 1 down.
All right, y'all, so let's do it. Bring the 1 down, then what are you doing?
1 times 6.
Uh-huh. So 1 times 6.
6 goes under the 13.
There you go. So then
And
what's
then
Negative 7.
negative 7? Good job.
somebody else.
It would be negative 42.
So negative 42.
And then that equals 10.
That's going to equal 10. Good job.
And then that would be 60, which equals 0.
There you go. 60 and a remainder of 0. So that means that our f of 6 equals 0. So that means if this thing has a maximum of 3 zeros, I know 2 of them are going to be 2 and 6 because my remainders were 0. But y'all, at this point, all they want to know is these function values, okay?
I don't know if I like these or the ones with the H's better. I don't know. I kind of like them both.
Yeah, I love this because you can do so much with it. So if you really love that stuff with the H's, take you some business calculus.
I don't know about that.
That's their thing. That's one of their big formulas for that class.
I don't think I'll need that class, but if it comes out that I do, I mean, I would. But.
There you go. All right, y'all. So let me.
Are we going to go over what we need for this support?
Yeah. So.